Okay, so finally we get to work on some examples in this section. Stuff we did before was very valuable, but I think that seeing examples will actually help you remember it. So we're looking to solve y double prime minus 4y prime plus 4y equal to x plus 1 e to the 2x. And I'm going to go ahead and tell us right off that note y double prime minus 4y prime plus 4y equal to 0 has solutions y1 equal to e to the 2x and y2 equal to x e to the 2x. Now remember, we already know how to solve constant coefficient non-homogeneous equations using undetermined coefficients. So technically we don't need variation of parameters to solve this problem. Variation of parameters could solve even like more difficult problems where you don't have constants in front of y prime and y. But sort of you don't know how to find y1 and y2 for those type of problems in general. So that's why we're doing this example here. But I think yp should be equal to u1 y1 plus u2 y2. And so my y1 and y2 I've already been given are u1 e to the 2x plus u2 x e to the 2x. My y1 and my y2. In general, when you have this type of problem, you'd have to find your own y1, y2. Now I know that when I do this formula for u1 and u2, I'll need derivatives of y1 and y2. So I'll go ahead and say y1 prime is going to be 2e to the 2x, and y2 prime is going to be e to the 2x, let's see, times x, oh wait, no, e to the 2x times 1 when we take the derivative of x, plus 2 times x when we take the derivative of e to the 2x. And then I'm just going to go ahead and compute all the things that I need to find u1 and u2 prime. So then we have y1, y2 prime minus y1 prime, y2 is equal to, let's see, e to the 2x times 1 plus 2x e to the 2x minus 2e to the 2x times x e to the 2x. So I'm going to go ahead and have e to the 4x from e to the 2x times e to the 2x. That's also here. So then I can pull everything inside of a common parentheses. I've got 1 plus 2x minus 2x. So it's just e to the 4x. And so my u1 prime is going to be, actually I'll give myself a little more room. My u1 prime is going to be that minus y2f over y1, y2 prime minus y1 prime, y2. So let's see, my y2 was x e to the 2x. My f was x plus 1 e to the 2x. And the thing on the bottom was e to the 4x. And my e to the 2x is on top and my e to the 4x on bottom will cancel out with each other. Remember, e to the 2x times e to the 2x is e to the 4x. So I'm actually just left with minus x times x plus 1, or minus x squared minus x. And my u2 prime is going to be y1f over the same thing. So I've got e to the 2x times x plus 1 e to the 2x all over e to the 4x. Same simplification as before, leaves me with just x plus 1. And so from here, I have to find u1 and u2. I have their derivatives right now. So I can find u1, the integral of u1 prime, and u2, the integral of u2 prime. And I'm going to continue that here. So I've got u1 equal to the integral of, I had minus x squared minus x. And u2, I have x plus 1. And so when I take those integrals, I get minus 1/3 x cubed minus 1/2 x squared on top, 1/2 x squared plus x on bottom. I might have, when I take these integrals, I remember that they are indefinite integrals, so I should add a constant on the end. It's actually going to turn out that those drop out, but we'll hold on to them just to be kind of thorough. And then my y sub p was equal to u1 y1 plus u2 y2. So I just plug everything in. I've got minus 1/3 x cubed minus 1/2 x squared plus a times y1 was e to the 2x plus 1/2 x squared plus x plus b times x e to the 2x. And so I'm going to go ahead and simplify that a little bit. My e to the 2x I'll pull out in front. I've got minus 1/3 x cubed minus 1/2 x squared plus a plus 1/2 x squared times x, so 1/2 x cubed plus x times x, x squared plus b. And my let's see, I've got minus 1/3 plus 1/2. Let's just do it on the next line. Minus 1/3 plus 1/2 will give me 6. Minus 1/2 plus 1 will give me 1/2 x squared plus a plus b. Oops, sorry, I forgot. That was b times x right there. Okay, so the solution is y equal to c1 y1 plus c2 y2 plus y sub p. So that's going to be c1 e to the 2x plus c2 x e to the 2x plus 1/6 x cubed e to the 2x plus 1/2 x squared e to the 2x plus a e to the 2x plus bx e to the 2x. But I'm going to note that here's a c1 e to the 2x and a e to the 2x are going to kind of combine together for just some c1 tilde e to the 2x. My c2x e to the 2x and my bx e to the 2x are just some c2 tilde x e to the 2x plus 1/6 x cubed e to the 2x plus 1/2 x squared e to the 2x. And then that's just my general solution. What happened in that last step right there was, remember, when we have a second order differential equation, if we have an initial value problem, we'll get two conditions that we can solve for two unknown constants. So this a and b we have no way to solve for, except it doesn't matter because they belong to the same term as part of the fundamental solution set for the homogeneous equation. So if you want to, when you're taking these integrals, you could just skip having the a and the b everywhere throughout. And then you wouldn't have to worry about this tilde thing. In the end, those terms will always multiply by y1 and y2. So you're just going to end up with repeats of c1y1 plus c2y2. If it helps you to hold on to those when you're integrating, that's fine. Just remember to cancel them out in the end.